Hey, this is Danny. This is a case study using SeaDAS. Although the focus will be SST anomalies, the concepts can be applied to other ocean color data products. I've broken this up into many parts. Each part represents a tool or concept in SeaDAS. You may watch the whole video or go directly to a particular part by following the link provided on the SeaDAS website. Ultimately, we will produce the following image. This image represents a comparison of SST, sea surface temperature, with a long-term 14-year average SST for the same yearly time frame. I've chosen to use 2010 January as it was during the peak of the 2010 El Nino. In parallel, we will produce this image, which utilizes the same criteria but for January 2011, the peak of the 2011 La Nina. So let's get started. Let's get the data. Here's the NASA Ocean Color website. We go to Data Access, and we'll use Level 3, so the Level 3 browser. We want to find the MODIS mission, and then we want to find the sea surface temperature. For nighttime, we'll use 11 micrometer. The monthly by default at 9 kilometer resolution will be fine. We go down, we want to find December 2009. We're actually looking for January, but we need the preceding month. So December, January, February. Here's our El Nino event, and we can download the data here. We want the bin file. Save it. There's also SMI files. And for the La Nina, we'll get these 3 files right here. Additionally, we want the monthly climatology, which is the long-term monthly averages. And we'll get December, January, and February files. And here's the periods that those cover. Here's all the files. I've grouped them into 3 directories. December, January, February, in each. These are monthlies, so I want to create a 3-month file that's binned with these files. So in each directory, I've made a text file. Let's go to SeaDAS. Under Data Processing, we go Level 3 bin. GUI opens. We want to find our text file, which lists all the files in our directory. By default, it will start at your top, but it remembers where I was last. Select it. Let's rename this. Copy from the clipboard a name I already have made. And the output parameter is the data products we want. It only has one, so we'll just leave it. The default on the lawns is the whole thing, so we'll keep that and change this to netcdf. Run it. And while it's running, I'd like to point out that you can run this exact same command at the command line. Here's what that command would be for this scenario. Okay, it's finished. Let's take a look at it. Right here's the file. We'll note that it made a log file. We can look at that. And it lists all the files that went into it for future reference. And we do the same with the other 2 directories. Now we want to make an SMI mapped file from our Level 3 bin file in SeaDAS. Go to Data Processing, L3 MapGen. We select the bin file. It's given a default name based on a default product, which is bogus, so give it an actual product name. And up here, it automatically changes to a name involving that product. This isn't really what we want as our name, or I don't want it, so I copy the original name that I created and change it to mapped. Go down here to interpolation and nearest neighbor or bin, but the best is area, so we'll go by area. And we'll stay with all the defaults because for right now we want the full Earth. Click Run. And while it's running, here's the command line version of the criteria we just ran. It's completed. Click OK. Here we see it's created the mapped file and also a log file where we can see the I file that went into it. Here's the mapped file we just created. Let's go ahead and add land to this. Go to the land icon up here. We get the coastline and landmass GUI. And we can turn coastline off. I'm not going to use that. We can turn enabled on in all bands. We can select the color for the land mask. And up here, it gets a little tricky of what you want to do. In general, you want to go the same resolution as your file and a super sampling factor of 3, and that would be good. And we can run it by clicking create masks. But instead of that, I'm going to do a more higher resolution one for this case. I'm going to select 1 kilometer, and I'm going to go up to 9 on this because that will break down the 9 kilometer to ones, and this will give a more high resolution, better result. But this is going to take a while to run, and I'll show you why I'm going to do this shortly. Run it. The land masks are created. It's made 2 bands of water fraction, which is for the landmass and the water. And it's created a smooth band, which it uses for the coastline. It's created some masks right here. And what we want to do is we're going to want to save this file and use it later. So I want to get rid of some extraneous bands and masks. So I'll go here. I'm going to select all of these masks, and I'm going to delete them. Say yes, and I'm going to delete some unwanted bands. So go here, go to Edit, Delete, say yes, and I'm going to delete the flag. There's also a delete key shortcut. Hit that. Now all I have is land, and I'm going to save this. So right click on it. Save as. I'm going to convert it to beam DIMAP format. Give it a name that I've already saved. That kind of describes how I created this file, and save it. Now what I'll be able to do is collocate this file with the other files and any files in the future at 9 kilometer resolution, and it'll be consistent. If you don't do this, you'll need to remember your settings for super sampling and what your source resolution was each time you do it, especially if you want to do statistics. So this is a nice way of doing that, to have a consistent data set. In the future, we plan to have a 4 kilometer and 9 kilometer selectable land data set. But right now, this is a good workaround to that. I've got all the files that I've made so far loaded in the SeaDAS. I've got my climatology for the 3-month January. I got the 2010, the 2011, and also the land mask file that we made. So I want to, at this point, put all these files into a single file. It'll make it a lot easier to work with. To do this, we use the collocation tool up here. Collocation combines 2 files together, retaining all the bands. So we can pick 2 files. We'll start with the climatology and the 2010. We'll give it a name. I'm going to call it temp1 because I have to do this a couple times. It's going to go into this directory. And we'll give it a suffix. And we'll give the suffix down here for the dependent file. So what happens here is all bands within the reference file, which is the climatology, will get this suffix. All bands in the dependent file, the 2010, will get this suffix. We can use nearest neighbor because the mapping of all our files is identical. Run it. It's created a file now, right here. Select it as the reference, and select the next one. 2011. Rename the dependent that gets created. We no longer want to add suffixes here, and we'll call this temp2 and run it. There we have it. And lastly, we select temp2, select our land. We'll, instead of calling that temp, that's the final. And we'll remove the suffix from the land because these are all different named bands, so that won't conflict with each other. The collocation has finished, and here is the collocated file. It has the bands, the climatology for SST, 2010, 2011, and the land masks. There's the land band and the land masks, and here are all the masks that came. If we expand this, we can see the suffixes that got added to all these different masks. We're now ready to make our SST anomalies bands. To do this, we go to band math. I'm going to call this SST anomalies 2010. I'm going to make a real band. And I'm going to deselect the masks. Let's select January 2010, subtract the climatology, click OK, and we have the expression here. I'm actually going to lose this expression because I'm making a real band, so I'll just put it there in the description. Press OK. It's created our band. We'll throw some no data on that, and we'll put a land mask on it. Looking at our image, we see the El Niño event here in the Pacific, and this is represented by a color bar. You'll notice that the color bar by default, look at the color manager, used SST anomalies scheme, which is a custom scheme that I created. We'll look into that in just a moment. The bounds on this, -3 to +3. Looking at the sliders, here's our color bar, so we get an idea of the range of these colors, where this is degrees Celsius. Looking back at the file manager, if I right-click on my new band properties, I see my description here, so I can remember what it was. I've now done the same steps to create the La Niña event right here for the 2011 SST. Look at the properties. This shows the equation that I used in the description. And again, it's used a default color bar based on my custom scheme. Let's go ahead and close all the windows except for the anomalies windows. And let's view them tiled vertically. Go here to view all, we'll synchronize them, and that way we can see the El Niño and La Niña. We can synchronize the cursor as well. Let's add a mask to this. Go to Mask Manager, the Import Masks icon, and we'll add this mask that I've already made for El Niño region 3.4. Toggle it on. Right there, we see it. Go to 2011 and toggle it on there. And if we select it, click the pencil, we can see what went into the mask, the expression. Cancel. Now let's take a look at how I made that mask. Go to f of x. And you'll find the lats and lons for this in the constants. So go down here, there's our lat. And we'll make lat greater than equal to -5. And I can type it in as well. And I've finished typing it in. Press OK. Here's our mask. If you click on it, highlight it, we can name it here. Call this El Niño 3. And we can export this. Click on it. Go to the export icon. It defaults with the name of our mask, which is what we want. Save it. Press OK. And to check, we can try to re-import it. And there it is. Another way to add a mask for the region that we want to look at is to import a shapefile. Importing a shapefile will automatically create a mask. Go to Vector Import, Shapefile. I have my El Nino 3.4 polygon shapefile all ready to go. Import it. We see the vector popped up there. Right there is the vector. If we go to the Layer Manager, we can toggle the vector on and off. In addition to the vector, we have a mask. Right here, we toggle on and off. Right here is our geometry that we've imported from a shapefile mask. And previously, we made a mask via a math expression right there. If you want to display your geometry with just an outline around it so you can see the data, go to Layer Manager. We'll turn off the mask and turn on the polygon. You see it right here. We want to select it. You can do this by clicking here, or you could have done it by clicking there and there. So we've selected it. Go to the pencil, which is either here or this, same thing. And we just want to make the opacity of the fill 0. Close that. We see it's just an outline. Let's click outside of it so we see it. And it's white. We can change that. Right there, make it black. There we go. As we progress through this case study, I'm going to be saving files and sessions. This will enable us to return to any point along the way. To do this, let's first save the file. Right-click, Save As. This has already been converted to a die map earlier. I'm going to just change the name, save it. The file is saved. Now let's save a session. To save a session, we go to File. We're going to save As. And we'll give it a name. And put it in the Sessions directory. What the session does is it remembers what windows you have opened. We have 2 windows opened here. We have some masks we may have had turned on and off. It will remember all of that. And it will remember which files are in your session. So when you do session open, it should restore SeaDAS to how it is now. Let's try that. Session close. This GUI has popped up because it thinks I've changed the file because I've toggled on and off the mask. So I'm going to ignore this. Sessions close. I can close SeaDAS and then come back to it later. Do session open. Select my session. Click open. And I'm back to where I was. We notice that the Pacific Ocean is cut in 2 at 180 degrees longitude. So let's go ahead and reproject this. Go to Processing, Reproject. I'm going to select Equidistant Cylindrical, Projection Parameters. I'm going to set the central meridian at 160. I like that because it splits the continents decently. We'll keep the nearest neighbor sampling since we're just doing images right now. I/O parameters, let's go ahead and name it. And we'll run it. Our file's created. And let's take a look at 2010. Let's tile these vertically. And I'll view all for that. And I'll click no data, so I'm looking at the same thing, and we see the new projection down here. Here we have our reprojected scene. Let's go ahead and crop it so we just get the Pacific. What we're going to do is roughly size the window to what we want the crop to be. Go up here and click on the crop tool. It's going to default with the window boundaries. Take a look at geo coordinates. Here are my coordinates. And I can accept these, or I can type in my own. I'm going to go ahead and type in coordinates. My boundary coordinates are now set. Let's run it. And it created it very quickly because it didn't actually save the file. Let's open it. Here we'll zoom out so we can see the boundaries. We'll throw in no data. And we see all the raster data has been copied into the new file. Each one has been cropped. Now let's put some grid lines on our image. Go up to the grid line icon, toggle it on. What that's done is it's created a layer right there. It's called Graticule. It's an old name for it. We can zoom out to view the labels because the labels have been put outside the image. And we may want to edit some of the parameters. To edit the parameters, we use this pencil tool. Click it, pull it into view as best we can, and here we have all our parameters. Let's go ahead and turn off the corner coordinates. Click these four here, and we don't need the grid lines, in my opinion. Close this, and there's our grid lines. A note on this layer editor here, if you were to click on the no data layer, and then go to the pencil, you're now trying to edit the no data layer. So what you can do is just toggle on and off the grid lines, and that will select the grid line layer as your active layer. Now let's add a color bar to this. Go up to the color bar icon, click it. It comes up with the default parameters. We'll take a look at preview real quick. This is what our color bar currently will be. Looks good. We'll just change the name. Here we have our name. And we can either save it as a file or create the layer. We're going to first create a layer. Let's zoom all to get everything. And we'll want to back it out a little to get the grid lines because it doesn't currently recognize those in the zoom all. We see that the color bar has been added to the raster image. Clearly the grid line labels are conflicting with this. So let's quickly get rid of those. Click on the pencil. Toggle on and off the grid lines. And let's turn off the south labels of the grid lines. There we go. And perhaps we want the color bar a little smaller. To do this, go back to the color bar icon, and we can scale it. Let's try 70%. We're going to create it again, and there we go. I've repeated the same steps to the 2011 band, and we get this. Having it synced up right there, I can toggle between them. El Niño, La Niña. El Niño, La Niña. We now have an image that we're satisfied with. Let's go ahead and take a look at how to export this as a PNG file. We go to right-click on the image, Export Image. We have several choices here. We can go with the View window. If we go with the View window, we'll get everything within the bounds of this View window. If we go with Data, then we'll get only the data. And we'll get the data at the native resolution of the data, which we see here is the resolution. The View window is pixels of the monitor, so we see we lose a lot. So if we want to improve our View window, we could perhaps increase that we want to go a little bigger than the data to include the external portions of this image. I've exported 3 files based on the criteria I just mentioned. Let's take a look. Here's exporting in the data mode. This was the native width right here. The view window mode, if I stay with the resolution of the monitor, looks like this. If I go with the higher resolution of 2500, it looks like this. You can see it's cleared up a little bit. Let's take a closer look. Here's a comparison of the view window mode, which will include the color bar. You clearly see that the words in the 2500 are much better than the monitor level. And this works out because SeaDAS inside understands that this is vector data, the letters and the numbers, and remaps it to the higher resolution. Here's all 3 files zoomed in side by side. In the center, you see the data mode. To the right, the higher resolution view window mode, which looks pretty much the same as the data. And to the left, we see the lower resolution monitor mode. The view window mode has, of course, remapped your data to the new resolution. But if you're zoomed out and not seeing the individual pixels, then effectively there is no difference. You might choose to export your color bar separately from the image. To do this, go to the color bar icon, and all our parameters have been remembered. Here's the width of our color bar in pixels. This should be sufficient. If you have a lot of labels, you may want to ramp this up. Preview it if you want. Okay, and instead of create layer, you're going to click here, save the file. Take a look at the file, and there it is. I've exported this in transparent mode, so it can be laid on top of an image or next to an image, whatever you choose. Let's do some statistics on our El Niño and La Niña regions. Since I'm only interested in this area right here, let's go ahead and crop it out. I just zoom in to the area. Click the crop tool here. I don't care to be precise. Click go. Go down here, open it up. So now my file is much smaller and the reprojection will run a lot quicker. Let's go to processing, reproject. Let's rename it. Go to reprojection parameters. Find sinusoidal. And let's set the central meridian to the center of our region. Go with bilinear. Run it. It's finished. And now let's do our statistics. We'll select 2010. We want to use a region of interest mask. Without this mask, we'll be doing the whole file. So let's set our region of interest mask to the El Niño 3.4 polygon. And that's all we need. Right here is the Go button. And here's our statistics. Take a look at the La Niña. Same thing. It actually remembers our settings. So we go. And here's our statistics for the La Niña. Let's take a look at how to add custom color schemes and color bars. First, let's add a color scheme to the scheme selector. Right here, I've got SST Anomalies. This is my own scheme. The way you add this is you need to edit a text file. You go to this directory here. Take a look, and you want this file right here. Scheme selector. Edit it. And this line right here is what creates the entry in the scheme selector. First, we've got SST Anomalies is the name. We've got a min and a max that gets set, whether it's log mode, which color bar it uses, override. Override, what this will do is if you have a scheme name of the same earlier, this will replace that. and your description right here, which will appear as a tooltip. Let's take a look there. Scheme selector, mouse over, there's my description. Select the scheme, and there's the scheme setting. Just to illustrate, select the chlorophyll scheme. Got the chlorophyll color bar, the min and max log mode. Go back to SST anomalies scheme. Here we have my custom color scheme. The last point of note is that this text file gets read when SeaDAS gets launched. So if you edit it while SeaDAS is opened, it won't appear. You need to close SeaDAS and relaunch it. Then your color scheme will appear. Now let's take a look at how to create a default color scheme which triggers off of the band name. If we go to Reset to Defaults, this will reinitialize the color scheme to the band name. Again, chlorophyll. This is of course not the color scheme I want, but I deviated away from it, so now when I do Reset the Default, you see it reappears, giving the scheme name right there. So let's take a look at how to add a default scheme. We go to our color palettes directory here, and this time we're going to edit this file right here. Scheme defaults user.txt. And here's the line we needed to enter. It's basically the same as the selector line. Here's our name, so we're looking to match the band name with this name right here. And your min and your max, your log mode, your color palette. In this case, override will use this one. If a previous one existed, it will ignore that one. If we save this file, close SeaDAS and reopen it, it'll read this file, and then any band which is called SST anomalies precisely will get this color scheme. Additionally, we have the ability to put wildcards in this, which I've done right here. So in this case, if the band name starts with SST anomalies, then we'll use the scheme previously defined SST anomalies. Likewise, if it ends in SST anomalies, here's how you would do a wildcard. Here, override takes on a slightly different flavor. Wildcard SST anomalies would in fact override SST anomalies if override is true. If you set this to false and your band name equals SST anomalies exactly, you would use this scheme instead of this scheme. And that's about it. Here's some wildcard examples. This is all in one file. Basically, if there's 3 entries, it's more in a wildcard mode. And if there's more entries, it's in the direct mode. And that's how you create a default color scheme. Let's take a look at how you can make your own color bar. In this video, I have my own color bar in here, anomalies2.cpd. Currently, it's convolved with the scheme, so it's going -3 to 3. Take a look, here's our colors, and -3 to 3. However, the actual color bar does not go from -3 to 3. Let's reload it. I do load CPD file exact values. I find it in my menu here. Hover, there it is, anomalies2 CPD. And there is the actual color bar that I created, which goes -1 to 1. Look at the table. -1 to 1, even distribution of the points, and here's our colors. This is actually a text file that's being read in when SeaDAS gets launched. Here in this directory, the .cdas directory with the color palettes, we find my CPD file. If we take a look at it, it's right here. We see for each of the points, we have an RGB color along with its value. You need to have the number of points and a few Boolean values. So to create your own color bar, you could just create your own text file with the suffix .cpd. and put it in this directory. Alternatively, you can create it using the GUI. To do this, first you want to have a basic idea of the number of points which your color palette will be. This one is 5. So let's try to recreate this one. So we want to find one that has a similar number of points. I happen to know that my grayscale.cpd file is only a few points. Take a look, and that's 6, so that's pretty close to what we want. So let's see how to change the number of points. Go to sliders. It is crunched up here, so let's go ahead and spread it horizontally. And you'll notice if you right-click on any of these sliders, you can add a new slider or remove it. Let's add it. We're now at 7. But what we want is 5, so let's go ahead and remove 2 sliders, and we'll be at 5. Now for my color bar, I want these distributed evenly. Take a look at the values. Here are the values going 0 to 1. But what I actually want is the values going -1 to 1. And I can edit these values right here. And I could edit the rest of the values. Another way to do this is distribute evenly and go over here and set your range. So you wanted to go -2 to 2. Take a look. And we've gone -2 to 2. Let's put this back to -1 to 1. Okay, so we're halfway there. We've got our numbers and the right number of points. So all we have to do now is get our colors. The middle will be easy. Click here, and we want white. It's at the very middle. The endpoints, we can go in here, and we can select one of the colors. Take a look at what the numbers are for it. And let's go ahead and do our endpoint here. We'll do a darker blue. And then go up here. We're going to go towards the red, the pink, and then the red. So that's a quick setting of the colors. We can fine-tune it to the ones we actually want by clicking the numbers. And for the one I'm using, I selected this value here. That for the blue. That for the intermediate leading up to the red. And finally for the hot one, the red. So we're almost there. We've got our color palette defined, the numbers, the colors. We see an asterisk here next to the grayscale.cpd. This means that these values have been altered, and what we have loaded does not represent this current file. So all we need to do is save the file, give it a name. The asterisk disappears because now the value loaded is the value of the saved one. If we go down in here, there's the old one, and there's the new one. So the new one exists now. Load it. There it is, -1 to 1. And wrapping up this case study, we see we've produced this image for El Niño 2010, and this one for La Niña 2011. I leave it to the future user to fill in this image. For more information, please visit the SeaDAS website.